Okay, now we're going to talk about cells. Let's say we have, specifically, we're going to talk about muscle cells, specifically a heart muscle cell with the myocardium we learned about yesterday. So here we have a myocyte, or muscle cell. And the first thing to realize about these muscle cells is they have a large concentration of potassium. If you're unfamiliar with K+, that's the nomenclature for a potassium ion. It has a positive charge on it. Outside of the cell, out in your body tissue fluids, there's a small amount of potassium, but it's very small compared to the amount that's inside. On the outside, we have a very large amount of sodium. We get that from salt, sodium chloride. Inside the cell, there is some sodium, but it's a very small amount. Now, from what we've learned about diffusion, there would be a natural tendency for sodium to try and rush into the cell and for potassium to rush out due to diffusion. The problem is that cell membrane, this thing that keeps everything together right here, selectively allows things in and out. And the way it does this, the easiest way to visualize this is that we have some sort of gates. These little brown gates here. These little brown gates are going to allow sodium to come in under certain conditions. And then we have some other gates, and let's make them green. And these little gates are going to allow potassium to diffuse. And so the potassium, when these little green gates open, would move out because there's a large concentration inside for a small concentration outside. Okay, so when the condition is right, and that will be when the cell becomes excited, which means it gets hit with an electrical charge, what happens is the brown gates open up, allowing this sodium and this sodium to equal out, which means that we're going to end up, let's go back to brown, we're going to end up with a lot of sodium rushing into cells in these little brown gates, trying to diffuse and equal out. This is going to change the electrical content of the cell. It's normally negative 90 millivolts on the inside. We have a huge amount of positives going in, and so our negative here is going to get slightly more positive. If we were looking at it on a chart, if this is 0, we're down here somewhere, negative 90. And when all that sodium starts rushing in, we're going to go up like this. But then what happens, let's go back to green, is the little green gates, once we hit a very, very positive state right here, these green gates open up, and guess what happens to the potassium? It starts rushing out. So the potassium's rushing out. Well, if we have a bunch of positives leaving the inside is now kind of positive, but if we have a bunch of positives leaving, what's going to happen is the cell potential is going to go down somewhat. Okay, so that's the electrical signature. That's what the graph would look like of our sodium and potassium moving in and out. And in the next discussion, we'll talk about what we do next, because right now what we have is a cell that's got a bunch of sodium on the inside and a bunch of potassium on the outside, and we can't do what we just did until we move the sodium out and get the potassium back in. We'll talk about that next.